Hello, welcome to video 2. Video 2 will answer question 6 exclusively. So question 6 asks, for each scientist in the table below, discuss their experiments including special equipment, their key conclusion, and how it changed our view of the atom. I want to start with Dalton. Dalton gave us his 5 postulates. And Dalton said that everything had atoms, that the universe was composed of atoms, that atoms were indivisible, as their name states, indivisible, that the elements had the same type of atom, that combinations would yield new products, and there was a set ratio, and that a reaction is a rearrangement of these atoms. So his conclusions, not really conclusions, he gave us compounds. He would mix things in certain ratios, and he found that he would get a product that was similar each time. And he had evidence to support his theories. It changed our view of the atoms. Actually gave us things to change about the atoms, because we found that they are not indivisible. We found things in them, and we also found that not all atoms are all the same. So let's go to Thomson. Thomson found the electron. So Thomson used a cathode ray tube. And using a cathode ray tube, he noticed that there was a bright stream of light going through the cathode ray tube, and it was attracted to a positive plate. Now, he found that there was a negative particle inside atoms. He called them electrons. And he also found that they had mass. Because Thomson discovered the electron, then we can say that Dalton's indivisible part of his theory is incorrect. And if it has a negative charge, then it must also have a positive charge. So then we have Rutherford, and then Rutherford conducts this gold foil experiment. In the gold foil experiment, he shoots alpha particles at a gold foil, and although most of the alpha particles went straight, some of them were deflected to the edges, and we can have our diagram like this, where we have the foil right here, and as the alpha particles shoot in, most of them go straight, but then some are deflected, and we have light being produced here on the film. The conclusion came to be that there is a dense positive nucleus that is mostly empty space around the nucleus. So it changed our view of the atom by giving us a positive nucleus. And then we have, last but not least, Bohr. Bohr gave us the Bohr model. And the Bohr model says that the positively charged nucleus is surrounded by electrons that travel in orbits. And this is what you did in 8th grade, and this is what we did a bit about in class. This can sometimes be called the shell model of the atom. And the Bohr model is just the electrons going in circles as if they were planets orbiting around an atom. He did give us quantized energy levels, and it explains why electrons don't go into the nucleus. It also talked about the energy level of hydrogen going up and down, and this is what we talked about when we had the light being emitted from our metals or metal ions. And it gives a simple diagram of electrons and how they orbit the nucleus, but now we know that we have a three-dimensional orbit with the orbitals in the quantum theory.